solar system is one of many. One star, the Sun, the planets, Venus, Mars, Jupiter and the rest, and of course our own Earth. Are there other solar systems? Surely the answer is yes. With me, two experts, Doctors Christian Tott and Lewis Dartnell.
Evening, Patrick.
First of all, what do we think about finding other solar systems?
Well, the first thing I think, Patrick, is that it's incredibly difficult. And for hundreds of years, people have speculated that there might be planets around other stars, but we haven't had the tools we've needed or the techniques we've needed to go after them until recently. And the key, it turns out, is to look very closely at the stars themselves. And the first method that was used to discover planets is called the wobble method, the radial velocity method. So I think I'm going to demonstrate this by picking up the Sun over here, so we can only do on the screen. Actually, this isn't the Sun, this is a distant star. You've got a big, juicy, gaseous planet there. What I want you to imagine is that this planet is orbiting the star, and what's happening is that the star's gravity is pulling on the planet, but the planet's gravity is pulling on the star. And so the star is drawn towards the planet, and so we get this slow wobble back and forth as the planet moves. Now, it's not a very big wobble. In our solar system, more than 99% of the mass is in the Sun, but it does wobble nonetheless at about walking speed, a few meters per second. And by looking at the star's light, by looking very carefully at the light we get from the star, we don't see the planet, but we do see this wobble. And then we can detect that there's a planet there. And Lewis, we can find out something about the planet itself.
Well, we can, because we work out roughly what the mass of the star is. We can work out from how bright it is and its colour and characteristics of the star.
Stars.
We understand stars well. We've been looking at them for thousands of years. Using this method, and we first discovered a planet orbiting a main sequence, a normal star, back in 1995. And so today we are very much in the golden age of discovering new worlds orbiting other suns in our galaxy. It's like being back in the 1500s and discovering new continents. We're discovering new worlds now.
Have we any idea what these planets can be like?
The very first planets we discovered were the easy ones to spot. They were the fat, gassy planets, the gas giant planets like Jupiter and our own solar system. And they tend to be orbiting very closely to the star, because then you have the greatest effect on the tugging of the star back and forth.
So the closer they are, the bigger the wobble. And so the first planets we found were these hot Jupiters, these very big planets, often bigger than Jupiter, very, very close to their parent stars, orbiting in just a few days in many cases. And they must be weird worlds, don't you think?
It must be weird indeed. I am prepared to believe that somewhere in the universe there may be an intelligent astronomer who looks like a cabbage and squeaks like a mouse. But I can't actually prove it. On the other hand,
I
was going to say, I thought you were describing some of our colleagues there, Patrick, but perhaps not.
We have started to read the chemistry of some of these extrasolar planets' atmospheres, and people have spotted the signature, the fingerprint in the spectrum and the kind of colour of the lights coming from the planets. They've detected water vapour and carbon dioxide and methane. So the beginnings of chemistry characterising what these planets are like.
There are three things needed for life.
What about Jupiter's moons, though? Because if you put one of these hot Jupiters and it has moons just like Jupiter or Saturn do, maybe they're worlds where life can exist.
Exactly. So you need the right kind of world to host life. Perhaps a rocky world like Earth, or maybe an icy world with a molten ocean, water ocean beneath it, something more like Europa. But it's not just the kind of world you need, but the location of that world in its solar system. So we can perhaps demonstrate this, keeping with our sun that Chris has got there. I'll pick up our Earth. Now, our Earth has a particular orbit around our sun. It's an orbit that takes 1 year, and it's a surprisingly circular orbit around our sun. But the distance of the Earth away from the sun is very, very important. It's the right distance from the warmth of the campfire, that the temperatures on Earth are just right for life. And if the Earth was closer to the sun, perhaps like Venus or Mercury, it would receive too much heat. Now its oceans of the Earth would have boiled away. It would be a hothouse, greenhouse world like we find Venus is today. If the Earth, in fact, had formed further from the sun, from the heat of the campfire, it would have frozen. It would have frozen over. They become like Mars. So Earth is kind of in that sweet spot between being too hot and close like Venus, being too far away like Mars. And Earth orbits in this magical region this ring around every star, and you can calculate it for different kinds of stars, where the temperatures on planets orbiting within that zone, within that habitable zone, will be conducive for liquid water and therefore possibly life. And it's those kind of planets we're most excited about trying to find.
And in fact, we've just found one. So the first planet in its habitable zone to be properly confirmed was announced just a few weeks ago. So that was Kepler 22b. Terrible name, but never mind. And that was found by a different method, called the Wink method. So, well, maybe I'll be the sun again.
Yeah.
Imagine this Earth-like world is Kepler 22b.
And it can orbit in different ways. And you can imagine that with any solar system, just like our own, you have all the planets orbiting in a particular plane. Just by chance, some of these alien solar systems will be inclined and angled directly towards us from our telescopes on Earth. So you'd see it orbiting around like this. And so from this point of view, you can see the planet passing in front of the star, blocking out some of its light as it transits or kind of creates an almost mini eclipse of that sun. We know its radius, we know its size, we know it's just over twice the width of Earth. We don't know its mass. We think it could be up to 30 Earth masses if it's quite gassy like Neptune. In the best case scenario, it might be all the way down to 10 Earth masses. So it's still a super Earth. It's still a very massive, heavy planet compared to our home world. But if it's a water world, if it's covered with more ocean and less rock, then it might be down to 10 Earth masses. But it would still have substantially greater gravity. You'd probably, if there was life here, you'd be on an ocean world, and to be able to support a lot of your weight, perhaps as a whale, with kind of the water buoyancy, taking all that weight that the gravity's putting you down with.
It's a wonderful thought, isn't it? The whales of Kepler 22b.
Yeah.
Well, I have to say, I get sick of remembering catalogue numbers. I mean, Kepler 22b I can manage, but Gliese 581 B, C, D, and E.
Enough trouble with asteroids.
Exactly. People named asteroids. There are plenty of those. Would you name extrasolar planets, Patrick?
I would, yes.
Yeah, what would you call them? What's your first nomination?
Nemo.
Nemo? Why Nemo?
The unknown.
Oh, okay. I like that. I'm going for Chris. I think would be good, and Lintot would be a good second one.
For its moon, maybe.
Yeah, sure. But the point is, names are memorable, and these are worlds.
Whole worlds. There's a lot of imagination, and they've got their own climates and atmospheres.
Tell you what was surprising, though, and that's the recent discovery, if you believe the results, that everything we've been saying, all of these planets orbiting their stars, they may be in a minority in the galaxy. Or at the very least, there may be a whole other class of planet out there, and these are the free-floating planets.
What can these worlds be like?
Well, they must be reasonably large, I think, to account for the signal that we see. So we're probably talking Jupiter. They must be freezing cold, because they don't have starlight. What happens to Jupiter if you chill it down to minus 270? Does it solidify?
Not all the way through, so that the point about a lot of these free-floating planets is they've still got an atmosphere around them. They might have been ejected a long time ago, but they've still got an insulating atmosphere, and so at the bottom of this, it may still remain warm, and they've got a lot of internal heat.
Just like Jupiter and Saturn still give out more heat than they receive.
So perhaps even a super-Earth, if it gets ejected into the cold depths of interstellar space, it'll cool down, a lot of its atmosphere will kind of condense and freeze onto the surface. But underground, you've still got a lot of that internal warmth being insulated and possibly habitable conditions. And so possibly these free floaters are the most frequent habitable areas, the most frequent life-bearing planets in our galaxy.
The estimate I saw was there might be 100 billion of these things. 100 billion free-floating planets. What strange astronomy these people must have.
If you could develop intelligent life on them.
But imagine if they did. They would, and they got to the stage we're at now, and they would only now be realising that there are planets around stars.
Which would be freaks for them.
Exactly.
We'd be the anomalies of the galaxy.
That's a bizarre and slightly scary thought, don't you think? Actually, we should talk about, because I know whenever we talk about extrasolar planets, there's something slightly unsatisfactory about the fact we can't see them. We have all these methods, we've got the wobble and the wink, but there's no real substitute for seeing these things. One of my favourite results from the last few years was the first images of extrasolar planets.
Agree on that.
In orbit, particularly, I don't know if you can remember, do you remember the Fomalhaut picture?
I certainly do. It almost looked like of Saruman.
The image looks odd because you've got to mask out all the light from the star. But then you can see this tiny speck, and then you can see it move over years. And for me, that's real. That has to be real.
I always say that I believe in these things once we saw one.
Mm-hmm.
And now we have.
That's right.
We've been talking about life as we can understand it. And what about entirely alien life? You kind of find the fictive stories.
Well, I suppose as an astrobiologist, you need to keep quite an open mind. You don't want to be too blinkered and think about only the things that we already know. Because as a scientist, you want to keep your options open and look elsewhere and look into other possibilities. But I think, at least for the time being, as we're exploring Mars and hopefully places like Europa and Titan again in the not too distant future, you want to be focused on what you know works. We know that water-based life and carbon organic life works. And perhaps in the further future, if we don't find any organic life on a place like Mars, we might want to think about exotic life on a place like Titan.
What about looking at the atmospheres of these planets? Because we're not far off. The next generation of really big telescopes might be able to take a very close look at the atmospheres of some of these planets. We'll be able to see if life exists from there?
In principle, we could. So if we look at some of these Earth-like planets that Kepler or other techniques we've been talking about can discover, and the next 5-10 years we might have a short list of Earth-like habitable worlds nearby us. We want to check them one by one with next generation telescopes and look for the signature of oxygen in their atmosphere.
I think the problem of whether there's life in the universe, with the discovery of all of these planets and with the imminent discovery of Earth-like planets around inhabitable zones in sunlight systems, I think has probably shifted from being an astronomer's problem to being an astrobiologist's problem, or maybe even a biologist's problem. It's about what do we understand about evolution, how does life get started, and so on. But it's all the more fascinating for that. It's just going to be a little harder to get the answers. Well, Patrick, we've been talking about these marvellous discoveries from the Kepler spacecraft, and just a few months ago I caught up with Bill Borucki, who's the man behind it, and he was fascinating. Since 2009, the Kepler spacecraft has been staring at a small patch of sky, monitoring 150,000 stars. It's looking for tiny dips in light as planets pass in front of those stars, and it needs 3 of those winks to be seen before the team can be sure they're onto something. Bill Borucki is the leading light of the Kepler mission and is proud to have discovered a multitude of worlds, some normal, some exotic and strange. I caught up with him at the recent planetary conference in France.
Of course, we have a lot of candidates, and we go through a lot of processing to make them announcements. But the ones that we've announced as firmly as planets, I think some of my favorites are the fact that we now have one that has 6 planets orbiting it, transiting it. We have one where the planet orbits a pair of stars, just like in Star Wars.
Oh, yeah.
Okay? So you see 2 stars in sunrise, 2 stars setting in sunset. Because in Star Wars you see Luke Skywalker looking off at the distance. You see these 2 stars setting on the horizon. What Lucas got wrong, of course, was he made the blue star small and the red star big. Just the opposite's the case.
Okay,
the blue star is big one, the red star is small and dim.
Excellent.
So we've talked to him about that. He said he'll try to get it right next time.
That's rather nice. So, I mean, what this is really telling us, isn't it, that it must be telling us that planets are rather easy to form, I would think. If you see them around many stars and you see this diversity, is that a correct conclusion?
If we want to find an Earth around a star like the Sun, if it's the small size that you're talking about, the size of the Earth, you can find that in a week or a month. But the habitable zone, where the temperature isn't boiling, then you have to have an orbit very much like the Earth's orbit, so you have to wait 3 years for those. But we are finding small planets, and we are finding around stars like the Sun, but their orbits are too short.
We could begin to think about how many large planets there are and how many Earth-like planets there are. Do we have a sense yet of which are more common? Is a typical planet like Jupiter, or are there more small rocky bodies?
All the evidence that we have is that the Jupiters are rare. The Neptunes and the planets that are sort of supersized Earths seem to be much, much more plentiful, like 10 to 1.
Okay, and so that would be from a few times the size of the Earth.
When you think about these objects, you're really asking, are they rocky?
Right.
Yeah, because if the planet's a gas planet, even though it's fairly small, there can be no surface. And we don't think there's any life because it's hydrogen. Anything heavier than that,
moons, though.
It might have moons. And so that's interesting. We're finding a fair number of Neptunes and Jupiters that are in the habitable zone of their stars. But we don't think to be life on the planets, but if you have moons, the moons are around the planets, and therefore they're inhabitable zone. And so you could imagine that you had a Jupiter inhabitable zone and had 3 or 4 moons like our Jupiter does. They're all the size of the Earth. They have atmospheres. They have people on them. They go from one place to the other for vacations, or to visit relatives, and so on.
Do you have a sense of when we will have a good sense of what the population of planets out there?
We know we still haven't got to the point where we're finding Earth's inhabitable zone. We don't have a lot of confirmed objects in habitable zone, so we certainly need more there. But people sometimes say, we've found quite a few Jupiters now. Don't you have enough? It's something like asking Darwin. You've seen one finch, haven't you seen them all?
Yeah, whereas there's actually the variety is the point.
The variety is the point. Those differences tell you about their formation, their structure.
Well, in the meantime then, more finches, and I hope you come back and tell us about them. So, thanks a lot.
I look forward to that.
My pleasure. Kepler has recently found Kepler 20e and 20f, 2 rocky planets orbiting the same star, each roughly the same size as Earth, but neither of them in that magic Goldilocks zone. As the mission rolls on, discoveries like these means it's just a matter of time before Kepler finds a planet like Earth, not too hot and not too cold, and then the hunt will be on to see if there's life out there.
We've been talking about other planets, but how are they formed? Well, now, we meet the 2 Chris's.
Well, this used to be so simple. We thought we understood how our solar system formed, but the presence of things like hot Jupiters and so on have really confused the picture. I think, Chris, we have to start with star formation, right? Because before you form planets, you've got to form the star.
Yes, so a star forms from a huge cloud of gas and dust and the stuff that's out in space, and over tens, hundreds of millions of years, that collapses down just by gravity, and in the end, the density and the temperature get so hot in the centre you form a star. But that's just in the centre, because you've still got this entire cloud of stuff around it. And over, again, tens, hundreds, millions of years, just that kind of time scale, that flattens down into a disk of gas and dust. So no planets yet.
I think, if I'm right, the tricky bit is going from dust and gas all the way up to nice, beautiful planets.
So I'm going to give you a wooden spoon.
Okay.
No insult intended, but
no, that's fine.
Would you please stir the bowl in a nice, even manner?
Okay.
So what we've got here is that the water in the bowl is the disk of gas that is orbiting the star.
About the right speed?
That looks about right, yeah.
Okay.
So we have here some pepper, and the pepper is going to be the dust, and we shall see what happens. So, if you take the spoon out,
okay, so the water's the gas.
So the water's spinning. I'm just going to sprinkle some pepper on there, and very quickly the grains of pepper group together into clumps.
They sort of do, don't they? It's a bit Spiral Galaxy-esque.
What happens to a protoplanetary disk, as we call them, is not too dissimilar to what happens in a disk of gas and dust in a galaxy.
So why is the pepper clumping together?
So the pepper clumps because the tiny grains actually stick together.
Okay.
And in a similar way to little grains of dust in a solar system stick together. And I believe we now have our first ever amateur image of a protoplanetary disk around Beta Pictoris.
Oh, nice, which is one of the ones that has planetary systems around.
Yeah, I think it's got some planets there as well. So the first amateur image of another solar system that's come out recently, which is quite amazing, actually.
And your own solar system in a box.
Indeed.
Beta Pictoris. Chris and Chris, thank you very much. We had planets on view this month that we still have. And Pete and Paul are waiting outside to show us Jupiter.
Well, Happy New Year, by the way. Thank you very much, Paul. It's a bit of a wet, windy one and rather cold as well. I was hoping we'd see Mars and Jupiter earlier, but sure no.
Well, I've set up a pot of tea in the observatory so we can sit in there and wait and see if the clouds do part for
Aren't you a good chap?
I am indeed.
Well, some interesting things happening this year, Pete. We've got that transit of Venus, and of course we have some good meteor showers this year, because the moon's out of the way.
I'm really looking forward to the meteor showers, actually, because they have actually been ruined this year by the moon being in the way, as you say.
They've been quite awful.
But we've also got the sun, which is waking up at the moment. It has looked quite exciting, and there's been lots of prominences and flares and things going off. Now that's quite exciting, because if it carries on building throughout the year, that gives us a chance of seeing an aurora.
Yes.
So let's start off with the planets, and let's start off with the very first planet, which is Mercury.
Yes, a difficult object to see, actually, especially from cities. It's always really rather low down.
It said 1% of the population have only ever seen it, and I don't think that's true, because I think
Probably much less.
we've pointed out month after month. But during January, it can be seen in the first part of January in the early morning sky. If you look to the southeast just before sunrise, then you might be able to pick it up. But much more prominent than that is the next planet out.
Of course, the planet Venus. And quite good this year. It's going to get reasonably high in the sky for the planet Venus. And it's one of those friendly objects for amateurs with all scopes or even binoculars, because you can follow the phases really with binoculars, and certainly a large telescope, a new telescope will show
You can, but the other thing about Venus is that it's so bright. I mean, it can cast shadows, Venus. It's so bright that with the naked eye, it looks really stunning. In fact, if you go right towards the end of January, there's actually a lovely crescent moon very close to Venus in the twilight sky. And that's one of my favourite sights of all, I think.
Now, Mars is at opposition in March, so it is then visible all night and well placed for being able to see it.
It's actually not too bad, because it's not moving about a lot in the sky. It's actually very close to the rear legs of Leo the lion. It looks like a bright orangey star.
This time round, Mars's northern face is presented to us, so we
Yes.
have a good view of the North Polar Cap. And as it's now spring, that enormous polar cap is starting to evaporate.
Yeah.
And it fills the air, with fogs and mists. And
You get that rather interesting appearance to Mars, because one of the most prominent dark features on the surface, that V-shaped dark feature, the Syrtis Major, which actually I think always looks like a pair of white fronts.
says a lot about your imagination, Pete.
Possibly. Well, let's carry on out of the solar system now and go out to the next one, the biggest planet in the entire solar system, Jupiter.
Still blazing away.
It's been magnificent, hasn't it, over the last few months? But there's still plenty to be had with Jupiter.
There is.
It's actually in Aries. In fact, I think it flips over into the neighbouring constellation of Pisces, just jumps over the border this month. But with the naked eye, it looks quite stunning. A pair of binoculars, you can make out those 4 bright moons, the Galilean moons, which dance around the planet.
Indeed.
And then with a telescope, you can make out all manner of detail.
So on the subject of Jupiter, we have had a lot of wonderful images into our BBC Sky Flickr site. A lot of them illustrating really what we've just been talking about, those really dark barges, the intense brown colour in some of them, and of course the Great Red Spot.
And that region of turbulence which is behind the Great Red Spot. It's an amazing thing.
It is. We are so lucky to have an enormous gas giant like that nearby. Well, let's move on now to one of my favourite planets in the entire solar system, and that is Saturn.
Yeah.
Now, as you remember, last year there was that tremendous, phenomenal storm on Saturn. We've never seen anything like it, really. Really, it's an enormous outbreak, and it appears it's still going.
The easiest way to find it is to use that very familiar pattern of the plough or saucepan. If you follow the curving handle of the saucepan round, you come down to a really bright orange star, which is known as Arcturus. Carry on going and you end up at Spica, and Saturn is right next to Spica at the moment.
In the constellation of
Virgo.
And this time around now, Saturn is, again, got quite a tilt on it now. It's
about 14 or 15
it
degrees.
is. Its northern face is well tilted.
It is.
So we're getting a really good
view of the rings.
Rings, and it looks quite pretty, I think.
It is quite pretty. If you've got a telescope, then have a look and see if you can see that gap which is between the 2 bright rings, the Cassini division.
It's a good test of seeing.
It is actually.
You should be able to see it in a 6-inch reflector. Okay, so let's move out from the solar system. You have an interesting little deep sky thing for us.
Well, I think it's very sad as we go into the spring months, because the gorgeous constellation of Orion the Hunter rapidly disappears from view.
It's gone. He's off.
Well, because it gradually moves to the west, and then the encroaching twilight swallows him up really quickly, so you lose him. So if you go out towards the end of January, don't forget to go outside and have a look at Orion hanging there in the night sky. Absolutely gorgeous.
Plenty to look at in the night sky of January, Pete. We must have tea in the observatory more often.
I think it's getting cold, actually.
Let's try it.
And now for our news notes. Chris and Chris, What's happening in the universe?
Well, let's start close to home as ever. Let's start in the solar system with Vesta, where we've got these amazing images coming back from the Dawn probe, which has been in orbit now for a few months. And in fact, it's just reached its lowest orbit, which is just 130 miles above the surface of this tiny little world. And Vesta turns out to be quite an interesting place. But I think the most remarkable thing is down here near one of the poles, this giant mountain, nearly as big as Olympus Mons, one of the largest in the solar system on such a small world. And I don't think anyone was expecting that, was it, Chris?
I thought about that.
No, I mean, Vesta's proved to be a big surprise in some of the stuff we've seen happening on the surface, little rock slides, landslides of stuff, and the world is incredibly fascinating. I was lucky enough to speak to Chris Russell, the lead scientist of the Dawn mission, back in October. The Dawn spacecraft went into orbit around Vesta in August 2011 and is giving us a unique view of the solar system's second biggest asteroid. I caught up with Professor Chris Russell at a recent planetary science conference. Chris is in charge of the mission and is loving the surprises that Vesta is throwing at us.
We've learned that it was really a good place to go to, and that's important to me, because what we're trying to do is to go back in time and to learn more about the earliest epoch of the solar system. So did the surface record all these events? And we believe when we look at the surface that it's been a good recorder.
So this impact crater, it's about the same size as Vesta itself, right? Its diameter isn't comparable to that.
Right. Well, it's very large. We're trying to understand things like, what is the age of this structure? Is this structure more recent than the other surface or not? We haven't quite figured that out yet, because there are some areas on there that don't look like they have enough craters.
But in general, surfaces with fewer craters are considered younger.
And then the ones with heavily cratered are the old ones. And we think that we can use the cratering record to figure out how old the surface is.
Dawn has seen more recent features too, such as landslides, but the scientists are also looking for craters being formed today.
One of the team members asked us just before we got there and said, could everybody keep their eyes open for fresh craters that appear while we're in orbit? You know, take a look at those images when we get there, and then take a look at the images just before we leave and see if anything happens. So we might get one, so we should be keeping our eyes open.
Craters expose what's underneath the surface, and the fresher the crater, the better. Looking at craters on Vesta is our way of seeing what the solar system was made of 4 billion years ago, and seeing something for the first time is always exciting.
Every time you see something with higher resolution you've never seen before, you're surprised. Your imagination is great, but you can't really imagine what the surface is going to be like. The team is doing a lot of thinking right now and exchanging ideas, and it's sort of like a bunch of kids at Christmas, and they open a present and they say, hey, look what I got here, and then they share, and then they go and they open something else up and share the information they're getting.
Dawn will explore Vesta until later this year, and then it's on to pastures new at the solar system's largest asteroid, Ceres, where no doubt we'll be surprised and amazed yet again.
There's one other story we have to mention this month, Patrick, which is the first image from a camera, a rather obscure camera called Scuba 2, which we featured on the Sky at Night a few years ago. It's an enormous thing because it has to be cooled right down, because it's going to look in what we call the submillimeter, the region of the spectrum that allows us to look at some of the coolest things in the universe, the places where stars are about to form. They've had a huge struggle. It's incredibly technologically complicated. At one point, they couldn't even get access to their camera because somebody else in the laboratory had poured plutonium down the sink, or at least they'd been a spillage. They just had horrible luck. And so I've got to show you this image, which is the first results from Scuba 2. You've got the optical image there, and then filling in the gaps, the detection of light from this wonderful camera, which is going to help us understand star formation, and it's going to help us understand these dark galaxies. Of course, we can always find more news on the website, which is bbc.co.uk/Sky at Night, and you'll also find their newsletter number 124, which you wrote with Pete Lawrence about what to see in the sky.
Well, thank you both very much. And when I come back next month, I'll be talking about infrared astronomy. Until then, good night.
Exploring the stunning Great Barrier Reef here on BBC HT tomorrow, Monty Halls continues to dive the most beautiful natural wonder at 7 o'clock.